Hey guys, so this was one of your homework questions. In this question, you had a pendulum bob which carries a charge, negative charge minus q, and you have a positive charge plus q which is held at the point of support over here, right? So from this, he's asking to calculate what will be the time period of this bob when it undergoes oscillations, right? So this is a classic electrostatics plus mechanics problem, which is mostly asked in, which is a standard problem in most of your competitive exams, right? And the approach will be straightforward over here. This is once again, since it's an SHM question, the idea is we'll have to calculate the time period of this oscillation, right? And for any SHM question, you will try to arrive at these equations for a particle executing simple harmonic motion. A is equal to omega squared x or alpha is equal to omega squared theta, right? Where this is your case of linear SHM and this is a case of angular SHM. So if you mostly realize right now, this is an angular SHM question. So the equation will be trying to arrive at is alpha is equal to omega squared theta, where theta is your displacement of this particle from equilibrium position and alpha is the angular acceleration which this particle has, right? So we'll be using the same idea to solve this question right now, and that is we'll displace this particle by an angle theta. So imagine now that this pendulum has been displaced by an angle theta from its equilibrium position. So when this pendulum is displaced by an angle theta, we'll now calculate what will be your net torque acting on it, right? We'll first try to calculate when displaced by an angle theta, what's your net torque? And then from that net torque, we'll try to calculate what will be your alpha. And we'll try to get this alpha to be proportional to theta. And from this, the proportionality constant will be omega squared. Once we know the omega value, we know that time period will be equal to 2 pi by omega. So a standard approach to solve all SHM-based questions, and we'll be applying that same concept to solve this question over here as well, right? So I've displaced this particle by an angle theta right now. Now, what are your forces acting on this object? The forces acting on this object are, you have this electrostatic force of attraction, you have mg, and we also have a tension force over here, right? Okay, so what will be my net torque? Net torque is torque due to tension plus torque due to force plus torque due to mg. And we are calculating all these torques about the point of suspension, right? So torque due to tension will be 0. Torque due to force, your attractive force will also be equal to 0 because both these forces are intersecting at your point of contact. The line of action of the force is intersecting with the point of contact, with the point of rotation, your axis of rotation. So torque due to tension and torque due to force will both be equal to 0, which means we are only left with torque due to mg. And what will be your torque due to mg? Torque due to mg over here will be equal to r bar cross f bar. So r bar is equal to this length L. R bar will be equal to this length L. So L into, then your component of mg, or you can also write r bar cross f bar. So f bar is mg, and the angle between r bar and f bar is the angle between the tails, which is equal to the same theta. So it will become mgl sine theta, right? So your net torque is equal to mgl sine theta. And you can already probably notice that this is the same torque value you would have when you're doing a normal simple harmonic motion case. That is your simple pendulum having no charge, because as you see, the torque due to this force has become equal to 0 only, right? So, but proceeding ahead, so now these steps of derivation will be similar to whatever steps of derivation you had in simple pendulum itself, right? So you can actually directly conclude the answer from here is time period will be equal to 2 pi under root of L by G. But let me proceed with the steps. So steps over here is once you've found out net torque, we'll now try to calculate alpha. So alpha will be equal to mgl sine theta, that is your torque, divided by moment of inertia. And moment of inertia in this case will be equal to ml squared. So we'll get alpha to be equal to G by L, G by L sine theta. And the aim is to always get alpha proportional to theta, right? So we'll assume that this is only applicable for small angles. So if theta is small, we get alpha to be equal to G by L into theta, which means this term becomes omega squared. So time period then will become equal to 2 pi under root of L by G, since time period is equal to 2 pi by omega, right? So hopefully the question made sense. A pretty standard question, but a conceptual question as well. So hopefully the idea behind the answer is clear as well. See you guys in the next one.